All right, period 3, my favorite class to mess up. I created a problem that was a little bit harder than I wanted to, and I believe, gosh, I can't remember who, but somebody wanted to know the math. So here's the math. For everybody else, you don't have to know it, but if you're just curious how it's done, I did want to show you. So in doing the math, I actually found two angles that do the same thing. So we have one at 35 and one at 64. So hey, I didn't even know that. But here we go. When you're doing it, I always still like setting it up. So I'm going to start up from the very beginning. So you have something that's shot at an angle. We know it's 16 meters per second, but the unknown is the angle. So we want to find at what angle would the projectile move 19 meters in the horizontal and 3 meters in the vertical. So I'm going to set it up that way. V, I, V, F, A, T, D. Put in everything we know. V theta is V theta, oops, too big. V theta sine theta. A is negative 9.8 meters per second squared. T is unknown, but D we know is 3 meters positive. In the x direction, we have dx VCT. dx is positive 19 meters. VC is V theta cosine theta. And we don't know time. So these are the knowns that we have. You could plug in 16 to make it a little bit easier. So V theta is 16, so 16 sine theta. And then you have 16 cosine theta. So now you have this. We do know these two times are going to be related to each other. So we're going to use that for our advantage. We're going to solve for t on the left, solve for t on the right, and combine it or substitute. I think I did substitute. So here we go. Let's see, which one's easier? I think in the end it's about the same. Let's just do this side this time. dx is equal to VCT. And then we have dx is 19. I'm going to drop the units just to make it as clean as possible. 16 cosine theta t. I'm going to isolate the t, so 19 over 16 cosine theta equals t. So that's that side. On the left side, it's my favorite equation. D equals VIT plus 1/2 AT squared. We're going to plug in everything that we know. So it's going to get pretty messy. So we have 3 equals VI, which is 16 sine theta t plus 1/2 AT squared. So I'm going to make it a little bit easier for myself. I'm just going to solve that in my head. 1/2 of 9.8 is 4.9 and it's negative. So it's negative 4.9 times t squared. Okay. Now we're going to plug in this into this thing and make it this ugly contraption. So you have 3 equals 16 sine theta. I'm going to plug in this entity right here. 19 over 16 cosine theta. And then minus 4.9, this big contraction, 19, 16 cosine theta squared. Okay, so now we combine it, both equations. We have one variable now, which is theta, but we have this really ugly equation. So working it out, hopefully we could be able to solve it. So I'm going to try to simplify as much as I can. The 16s cancel out, and I get 3 is equal to, I'm going to pull out the 19, sine over cosine, so that's tangent theta, so that looks okay, minus, I'm going to pull out this number, but I'm going to square it first so I don't make sure I don't make any stupid mistakes. Where's my calculator? 19 squared is 361. 16 squared is 256. And then you have cosine squared. Ugly. Okay, cosine squared. Cosine theta squared. I'm going to simplify this, and then I'm going to change this to cosecant. So some trig identities that I'm going to take advantage of are these two right here. So let's see if I could find them really fast. Okay, some trig identities I'm going to find is right here. So the first one is 1 over cosine is secant, but now we have secant squared, so I'm going to use I believe this one, secant squared equals tan squared theta plus 1. So this is the one I'm going to take advantage of. So the ones that I just said was secant is equal to 1 over cosine, and then secant squared is equal to tangent squared plus 1. Let me just make sure I did that correctly. Secant squared is tangent squared plus 1. Secant squared is tangent squared plus 1. Okay, perfect. So I got that right. So here's our trig identities that we're going to use later on. But I want to simplify this so I could use those trig identities. So it's pretty ugly, but it gets better. 3 equals 19 tangent theta equals this number right here, which I'm going to simplify. 4.9 times 361 divided by 256. And you get minus 6.91, and then 1 over cosine squared is going to be secant squared theta. Okay, so now we have the following. So we have 3 equals 19 tangent theta minus, let me make sure I did my math right. I think so. Minus 6.91 secant squared theta. All right, I'm going to substitute this thing right here. So I have 3 is equal to 19 tangent theta minus 6.91. Secant squared is tangent squared plus 1. I'm going to distribute the 6.91. I'm going to move this 6.91 to the other side, so add 6.91 on both sides. So I get 9.91 equals 19 tangent theta minus 6.91 tangent, oops. And now I'm going to rearrange everything. I actually should have just pulled everything to the left. So I have 6.91 tangent squared minus 19 tangent theta plus 9.91 equals 0. So now I have a quadratic. I could substitute, when you're doing this, you substitute your tangent with just an x. So I will just do that. So 6.91 x squared minus 19x plus 9.91 equals 0. Plug this into a quadratic formula. So I'm going to do that right here. Quadratic formula calculator. I'll put in my numbers. 6.91. Oh, it's over here. 9.91. Calculates, and it's going to give me two answers. It's going to give me x is equal to 0.699 or 7. It's pretty close to 7. And then 2.05. So those are my two answers. And what I'm going to do is now I'm going to make tangent equal to that. So tangent of theta is either equal to 0.7 or 699, and then tangent is equal to 2.05. So you do the inverse tangent for this one, you get, so second tangent inverse 0.7, and I get 34.9935, and for this one I get 63.99, which is 64. So pretty much you get 35 and 64, and those are the actual two angles that I was trying to show right here. That gets it. So this is as close as I could get, you know, like 3 up, 19 across. It's a little off, but it won't tell me that right there, but it'll tell me the dot right before it. So it's pretty close. Like if I got this measurement, I'll get that. But yeah, so you can see that it's a little bit off, but it's pretty close. But that's exactly where it's going to hit. So both 64 and 35 degrees are going to hit that spot exactly. And then once again, here's the math. Do I expect you to do this? No, because you need to memorize the trig identities or even look at it. And even when I was looking at it, it took me about half an hour to figure it out. Just to figure out which ones work, just because you're just playing around with different combinations. Because this is a pretty nasty behemoth right here. So you just kind of have to look at it, figure out what can you manipulate to make it look like it. So the first lucky guess I did was the this one, deciding to use secant squared, and then I got tangent. And once they were both the same, you could actually solve it. All right, so hopefully that works. I apologize for giving you such a hard problem, but here is the math for it if you wanted to solve it.